In section 3, we're going to be working with the probability of multiple events. So in previous sections, we've just talked about the probability of one thing happening, but in this section, we're going to have more than one event. So what we need to first talk about is the difference between dependent events and independent events. So dependent events, in a dependent event, the outcome of the first event changes the probability of the second event. So the outcome of the first event changes the probability of the second event. An example of a dependent event is if I were to draw a card out of a deck and then I draw a second card out of the deck without putting the first one back. So the first time, say I have the probability of getting a queen would be 4 out of 52, but then if I don't put that card back, I only have 53 cards to choose from, so that's going to change the probability of the second event. So we call that without replacement. Versus independent events, where the outcome of the first event has no impact on the probability of the second event. So an example of that would be if I were to flip a coin and then roll a number cube, what I get on the coin is not going to change the probability for what I get on the number cube. Also, if I put my card back after I draw the first one, then it won't affect the second outcome. So we call that with replacement. So let's look at some examples and say if they are dependent or independent. Let's say I roll a die for my first event and then spin a spinner for my second event. If I roll a die and then I spin a spinner, will the outcome of my first event, rolling the number cube, affect the probability of my second event? It will not, so these would be considered independent. What if I pick a card, then pick a second card? Well, I would consider these to be dependent because it does not say we're putting the first card back, so it's dependent because we kept the first card. Since it says we pick a second card. And without replacement, we consider those dependent events. Okay, how about this one? If you have 5 coins in your pocket and you pick one at random, then you put the coin back and pick again. Would that be dependent or independent? Well, that's going to be independent because It's with replacement. We put that coin back. So all of my coins are back in my pocket, so I start fresh. Okay, moving on to multiple events. When they're dependent and independent, we're going to do kind of some examples after we talk about a probability formula that we need to know. It's for when you have two events that are going to be happening, the probability of A and B. Remember in math, so when we do things with probability with the word and, what we're going to be doing is multiplying. So if you see the word and in a probability problem, you're going to be multiplying probabilities. So the probability of A and B happening would be equal to the probability of A happening times the probability of B happening. So we'll look at some examples and talk about when they're dependent versus when they're independent and how that changes our problem. So for our first example, we are going to be at a picnic and we're going to have a cooler with some beverage choices, and we're going to have a box of snacks that we can choose from. So in our cooler, we are going to have 10 Diet Pops and 8 regular Pops. And in the box over here, we're going to have 8 bags of pretzels, and we're going to have 12 bags of chips. And what we're going to do is at this picnic, we are going to randomly grab a drink and a snack. So we have two events. Event number A, event letter A, is grabbing a drink. Event B is grabbing a snack. And I want to know what is the probability that you grab a regular drink, a regular pop, and a bag of chips. So we need to decide if these events are dependent or independent, and then we're going to write a probability statement based on these two events. So our events that we're trying to figure out would be the probability that we get a regular pop and chips. So that word and in there means we're going to be multiplying. So we need to figure out the probability that we get a regular pop times the probability that we get chips. Now the probability that we get a regular pop is going to be our first event. So that first event will be getting a drink. The second event will be getting a snack. And we want to know, are these dependent or independent? So the events are A, we pick a pop, B, we pick a snack. Will it change my probability of getting a snack based on what I get for my pop? Well, they're not even in the same containers, so it won't affect my second event based on what I get on my first event, so these will be considered independent events. So I only need to get this probability and multiply it by that probability. So the probability that I would choose a regular pop, there are 8 regular pops, so 8 ways to get a regular pop out of, there are 18 total things in my cooler, so it is 8 out of 18, times the probability that I get chips, which would be 12 bags of chips in the box out of 20 possible options. So the probability that I would get regular pop and chips would be 8 times 12, which is, let's see, 8 times 12 is 96, over 18 times 20, which is 360. And I think that's going to simplify, if I need to grab a calculator. So that would simplify to 4 out of 15. So we have a 4 out of 15 chance, which is 26.7% probability that we would grab a regular pop and chips. Okay, let's look at a second example. In my second example, I'm going to have a candy bowl. In my candy bowl, I'm going to have 2 strawberry candies. I'm going to have 4 peppermint candies. I'm going to have 1 root beer candy, 5 green mints. Sometimes we call those spearmint, but I'm calling them green mints. 2 butterscotch, and 7 cinnamon. Okay. What we are going to do is we are going to choose 2 candies. So you choose 2 candies. And we're going to do this 2 ways. We're going to do some problems with replacement, which means I put the candies back in the bowl after I draw each time. And we're going to do some without replacement, which means I keep the candy and I don't put it back in. So I am going to do like the same problem 2 different ways. So let's find the probability that we choose a strawberry and a cinnamon. So I have 2 strawberry and I have 7 cinnamon. How many total candies do I have? Let's see, 7, 8, 9, 10, 15, 19, 20, 21 total candies. So to figure out the probability with an and, remember I'm multiplying, so that's the probability that I choose a strawberry times the probability that I choose a cinnamon. Now, are these going to be dependent or independent? With replacement means that they are independent, which means the probability of the second thing is not changed by the outcome of the first. So the probability that I would choose a strawberry the first time would be 2 out of 21. And then I put that candy back in, which means I still have 21 candies in there. The probability I choose a cinnamon candy would be 7 out of 21. So the probability that I would choose a strawberry and a cinnamon would be 14 out of 441. Now, I would normally simplify that fraction, but I'm just going to leave it for now because I want to move over to the without replacement so we can see if those answers are the same or different. Oops. So I'm going to do the same problem, the probability that I choose a strawberry and a cinnamon, but this time it's without replacement, so that means they are dependent events. Now I still set it up the same way, the probability that I choose a strawberry times the probability that I choose a cinnamon. This time though, for choosing a strawberry, it's 2 out of 21. And then the second time, since I don't put that candy back, I chose a strawberry candy, which means now there's only 1 strawberry candy in there instead of 2, which means there's only 20 total in my candy jar. So now the probability that I choose a cinnamon, there's still 7 cinnamon candies, but now there's only 20 total candies. So now my probability is going to be 14 out of 420. So this was about a 3% chance. Well, we'll go to the nearest tenth. So 3.2% chance when I divide it. And then this is a 3.3% probability. Let's do a couple more of this type. So now I want to know what's the probability that I choose a cinnamon and then another cinnamon. And we're going to do this both ways. So with replacement, the probability that I draw that first cinnamon is going to be 7 out of 21. Now with replacement, I put my cinnamon candy back, and so now there's still 7 in there, and there's still 21 total, so it will be 7 out of 21 again, which will give me a probability of 49 out of 441, which is 11.1% when you divide that. Now without replacement, the probability that I draw the first cinnamon is 7 out of 21, but then remember that without replacement, I'm not putting that candy back. So now there's only 6 cinnamon candies in my jar, so it's 6 out of, and one of the candies is missing, so 6 out of 20. So we get 42 out of 420, which is going to be a 10% probability exactly. Okay, one last one of this type. Let's say we're going to choose a root beer, and I want to know the probability that I would choose 2 root beer candies. We're going to do this both ways. Remember, with an and, we're going to multiply those 2 probabilities, so that's the probability that I choose a root beer candy the first time times the probability I choose a root beer candy the second time, and that's not going to change over here when I get it started. So the probability that the first time I choose a root beer candy would be, there is 1 root beer candy, so 1 out of 21, and then I put that candy back, and the probability I choose that root beer candy again would be 1 out of 21 also. So that's 1 out of 441. I think that's going to be a pretty small number. It is. It's like that. So it is a 0.2% likelihood. What about if I don't replace that candy? Then the first time that I draw, there's 1 out of 21 chance that I draw root beer candy. But the second time, I drew the root beer candy out, so how many root beer candies would be left? There would be none left because I already drew it. And there will be 20 total candies. So that would be a probability of 0 out of 420, which is a 0% chance that I can draw 2 root beer candies if there's only 1 root beer candy in the bucket.